This is the 2015 Geometric Reasoning External, question 1. You can pause the video and read the question for yourself, have a go. So there's lots of information up here. It tells us that AE is parallel to HI, which is parallel to JN. So all of these lines here are parallel. The rack is symmetrical. BC equals CF, yep, I can see that because of those blips. Angle KCL equals 24, I can see that as well. Right, we're asked to find size of angle BCF, that's the coloured in one. Right, it's clearly 90 minus 24, which is 66 degrees, but we really need to go into some explanation of why, for example, that's 90 in there. So what we can do is state that angle LCM equals 24 degrees, and that's by symmetry. So that one in there is 24 degrees. Now angle BCF is going to equal angle DCG, and that's by symmetry. So therefore, to work out one of those, angle BCF, would have to do 180 minus 2 lots of 24, dividing that in 2, we get 66, and that's using angles on a straight line, sum 180. And I'm sure there's other ways you could prove that one too. Right, we're going to have to flick up and down between our picture. So part 2 says find the size of angle DGC, so we'll colour that one in this time. Once again, lots of ways we can do it. We've just shown that this one in here is 66, so we might use base angles in isosceles triangle to find BFC, and then symmetry CGD would be the same. So angle CFB will equal angle CBF, which would equal 180 minus 66 divided by 2. Which is 57 degrees, and that's base angles isos triangle are equal, and therefore angle DGC that we're asked to find is the same as angle CFB, which is 57 degrees, and that's because of symmetry. Right, we've done that one too. Now the height of AE above the ground is 1.2. We're asked to show that the length KL is 0.53, so let's go back and find AE. So the height of AE above the ground is 1.2 metres. So that means that length there, CL, is also 1.2. We've got an angle in here of 24, and we're asked to prove how long KL is. So I'm going to use this right angle triangle in here. I'm going to redraw it down here. So that's 24, that's 1.2, and this is the length we're looking for. I think let's see. Right, so this is the opposite side, adjacent, so we're using TOA, tan. Tan of 24 is opposite side, divided by the adjacent. So this is a multiplying problem. X is going to equal, if we multiply by 1.2, and that equals 0.53 metres to 2dp as required. Right, what is the length of CK? So you can pause, have a look back, have a look on your exam paper. CK is the slopey length actually, and if that's 1.2, and we've just shown that's 0.53, we want to find, that's CK there. We'll use some Pythagoras' theorem, which is a different skill. We haven't used that yet. So it would be the square root of 1.2 squared plus 0.53 squared, because we're looking for the hypotenuse. Working that out, 1.312 metres. And that's CK equals that. Right, CH is 2/3 of CK. So H is down here. We wanted the length of HI, remembering it's symmetrical. So 2/3 of CK, we've just worked out CK. So 2/3 of that, 87455. So that gives me that side there. And I want to find x now. So there's the hypotenuse. Opposite, we're using sine. Once again, we're multiplying the two. I haven't worked that out, but what I do know is that the length of HI will be twice that. So if we take that number, times it by 2, we should end up with 0.714. Alright, last question here. It's quite a different one, this one. We're told that Mn is in a ratio A to B for NQ. So we've got Mn, NQ in the ratio A to B. So what we'll do is we'll put an A there, and that length is a B. Now I can see that I've got two triangles in here, and we're asked to compare the areas of the two triangles, MNP and MQS. So I'm going to, good technique, I'm going to draw the two triangles out separately. That's A, and because it's symmetrical, that will be A as well. And the bigger one. Now the whole of M to Q, that side there, would be A plus B. And obviously it's symmetrical. Now there's lots of different ways you can do this, and you might do this a different way and still get the same answer, or a similar answer that means the same. I treat this as an enlargement. The small side there has been enlarged from A to A plus B. Now the enlargement factor or scale factor, the length of the image divided by the length of the object, so that would be A plus B divided by A. So we're saying that the bigger triangle is, the lengths of the sides are A plus B divided by A times bigger. Now when it comes to the area, how much bigger the area is always the scale factor squared times bigger. So in this case, the area of triangle MQS would be A plus B over A all squared times the area of triangle MNP. If you want to do some algebra on that, you could expand the top and expand the bottom as well. Anyway, we've been asked to compare the areas, and that's how it works. The area of the bigger one needs that factor there times the area of the smaller one.